3.3 stretches and compressions. So now what we're going to do is we're going to start dealing with, making it taller or shorter or wider or narrow. Okay, so given the graph, there it is right there. Bang, funny looking graph, right? Sketch y equals 2f of x. So basically what we're doing is we're taking all the y values and multiplying them by 2. So here's the original point. So -2, -1, 0, so you can see that. Now, the x values don't change. All we do is we take the y values and multiply them by 2. So -1 becomes -2, 0 becomes 0, 2 becomes 4. You can see that. So what does that look like? Well, we can do the solutions here. That's where we got all the points from. What do you notice about this? Well, it looks really similar to that one. The only difference is it's stretched 2 times as tall. So that's really nice. So when you're dealing with y values, right, you can see, let's move this out of the way. You can see the x values just stay the same. The only difference is the y values get larger, right? Now, what if that was, let's say, a half out the front? Well, that would make them half as tall, right? So that's really nice. When you're dealing with the y values for stretches and compressions, they're really, really easy to work with. Here's the problem, and this is the tricky one. It's when it's inside the graph. So for the same function, sketch the graph of f of 2 of x. So now it's inside. And this is counterintuitive. Like if you remember from quadratics, when we had in brackets x plus 2, it shifted it 2 to the left. Remember, it was kind of weird. So what we can do is we can look at different x values, and we actually can calculate all this out. And we're doing this all from the original values up here. And what happens is when we calculate these out, you'll see these numbers are smaller. So what happens is if we sketch this out, oh, it's a little tiny graph. So when the 2 is in here, you would normally think that it's 2 times as wide, but it's backwards. It's actually 2 times as small. So it would be like taking all the values and dividing by 2 or multiplying by a half. So for instance, y equals f of 2x makes it half as wide. Now, what would that mean if what would it be if y equals f of 1/2 x? That would make it 2 times as wide. So this is the part that's going to be the trickiest, is dealing with the x's in the middle, because it's backwards to the way you think. All this math up here was just to show you that. It's way easier just to memorize that, hey, if it's 2x, it's 2 times as narrow. If it's 1/2, it's 2 times as wide. Okay, so let's look at the second page here and look at this one here. So to cause a vertical stretch, right, it's easy. It's just outside. So a of f of x, right? So if it was a 5, it'd be 5 times as tall. If it was 1/5, it'd be 5 times as narrow. The horizontal one is the tricky one. So to make f of x twice as wide, use f of 1/2 x. That makes it twice as wide. To make it 1/3 as wide, it's f of 3x. Okay? So here we got an equation. Y equals absolute value of x. Stretch it 1/3 as tall. So that's easy. You just put a third out the front there because it's affecting the y, and it goes like that. Now, stretch it 3 times as wide. So you would think, oh, I put a 3 in there. No, it's counterintuitive. It's backwards, right? We put 1/3 because we could, if we wanted to, you could go through and do a table of values just like we did on the first page and figure this out here, right? F of 2x, f of 0 equals 0, right? And you just take the values and do that. We're not doing that. It's way easier, like I said, just to base it on what we know about compressions, horizontal compressions. Okay, so now the last part of this one is just a to the next lesson. It's just talking about, here's the general y equals f of x, just a standard polynomial equation, right? Here's what we're going to do. We're going to do a, b, c, and d, and this could be any values. These are the common ones. A is easy. Vertical stretch, right? You multiply the y values by a. Well, let's look at d next. D is just to shift vertically. If it's positive, it's up. If it's negative, it's down. Okay. B and C are the tougher ones. So let's look at B. It's a horizontal stretch by a factor of 1/b. So for instance, if it was 2, it would be a 1/2, right? If it was 1/2, then it'd be 1/1/2, which is a 2. If B is negative, you reflect it over the y-axis. So B and C are the tricky ones in this whole thing. Now, C is a shift horizontally, and that's the same as we did in grade 11. So for instance, if it was x minus 4, it would be a shift to the right. If it was x plus 4, it would be a shift to the left, right? Now, what do you got to do first? You always do your stretches and reflections, right? Which is your, right, stretches and reflections first before your translations, right? Always do your transformations, which is your stretches and reflections, before you do your translations, which is your slides. So what does that mean? You do your A's and your B's before your C's and your D's. That make sense? Okay. So again, we'll cover more of this in 3.4.